What is binomial distribution? A random variable x is said to follow binomial distribution if it assumes only non-negative values, and its probability mass function is given by p of x is equal to x is equal to p of x is equal to ncx p power x q power n minus x, where x takes the values 0, 1, 2, etc. up to n. Then, where here n and p refers to parameter of the distribution, and n is also known as degree of the distribution. Now, if we say that this is binomial distribution, what is binomial variate? Let's see. What is binomial variate? Here, binomial variate is nothing but a discrete distribution, and x can take only the integral values, that is 0, 1, etc. up to n. Any variable which follows binomial distribution is known as binomial variate. First, we can see binomial distribution of probability mass function. Probability mass function is nothing but we have to prove that it is equal to 1. Now, binomial distribution, we can write it as summation x is equal to 0 to n, p of x is equal to x is equal to p of x equal to summation x is equal to 0 to n ncx p power x q power n minus x. Here we have to apply binomial distribution, and x takes the values 1, 2, etc. up to n. Then if we apply in the above formula nc0 p power 0 q power n minus 0 plus nc1 p power 1 q power n minus 1 plus up to etc. plus n cn p power n q power n minus n. Now here nc0 is equal to 1 and ncn is also equal to 1. If we apply here, nc0 becomes 1 and p power 0 is also 1, q power n is remainder, and plus we have to write that those terms as it is nc1 p power 1 q power n minus 1 plus etc. Here we have ncn as 1 and p power n we have the remainder, and q power n minus 1 becomes 0. We just took the first and last term, then we have written q power n plus p power n. So the power is same, we can write q plus p whole power n. Using binomial series formula, we have p plus q is equal to 1, so that q plus p is also equal to 1, so 1 is 1 power n. Summation x is equal to 0 to n, p power x is therefore is equal to 1. Hence proved. The next question, we have to prove that moments of origin, nothing but three subdivisions: mean, variance and standard deviation. First subdivision, mean. Mean is nothing but mu1 is equal to e of x is equal to summation x is equal to 0 to n x into p of x. So the formula we have to apply for p of x, summation x is equal to 0 to n. Here there x exists, so x into ncx p power x q power n minus x. So next, summation x is equal to 1. We have to apply x is equal to 1, so that x into, for ncx it will become n factorial divided by n minus x factorial into x factorial, and there exists same, so that we have to write as it is. Then here we apply x is equal to 1. It becomes summation x is equal to 1 to n x into n into n minus 1 factorial divided by n minus x factorial into x minus 1 factorial, p power x q power n minus x. We just divide and multiply by p. So it is multiplied, then we get here x and x is cancelled, then we get n, then there is p, we write np, summation x is equal to 1 to n nc n minus 1, then divided by, we write the denominator as it is, n minus x factorial x minus 1 factorial p power x. Then in denominator, if it goes upside, it will become minus 1, so that p power x minus 1 q power n minus x. So we write as it is, but we are converting the upper n minus 1 factorial as ncx, so that n becomes n minus 1, then c x is nothing but x minus 1. Then we write as it is, p power x minus 1 q power n minus x. np summation x is equal to 1 to n. This is nothing but p of x is equal to x, which is probability mass function. It becomes 1, so that we get only np. Mean is equal to np. Hence proved. Now second subdivision, variance. It is nothing but mu2 dash minus mu1 dash the whole square. So mu2 dash is equal to expectation of x square is equal to summation x is equal to 0 to n x square p of x. So we write p of x as a binomial distribution formula, summation x is equal to 0 to n. Here we did one thing, that is nothing but we write x square as it is, then we have to subtract and add x minus x plus x. Then writing the formula for p of x, ncx p power x q power n minus x. First we separate x square minus x. So summation x is equal to 0 to n x square minus x, then multiply with the inner ncx p power x q power n minus x, then writing x into that formula. So here x ncx p power x q power n minus x becomes np by 1. First subdivision it becomes np. So we have only summation x is equal to 0 to n. We are taking x as common, so that x into x minus 1. Then ncx p power x q power n minus x plus np. We are taking this equation as equation number 2. Then we have to consider the first plus term alone. That is nothing but summation x is equal to 0 to n x into x minus 1 ncx p power x q power n minus x. Now if we apply formula for ncx, it becomes n factorial divided by n minus x factorial into x factorial. Then p of x q power n minus x. Now we take the value of x is equal to 2. So we get summation x is equal to 2 to n, then followed by the x into x minus 1, n into n minus 1, n minus 2 factorial divided by n minus x factorial, then x into x minus 1, x minus 2 factorial. Here x and x minus 1 factorial gets cancelled in the next step. We can see that. And we are multiplying dividing by p square. So that p square divided by p square. N. Then there is p square, so that we are taking it in front, p square. Here x gets cancelled, and x minus 1 and x minus 1 gets cancelled. We write n minus 1. Then the numerator and denominator as it is. Summation x is equal to 2 to n minus 2 factorial divided by n minus x factorial x minus 2 factorial. Then we are taking 2 to the upper, x minus 2 and q power n minus x. Then we are getting np square n minus 1 summation x is equal to 2 to n. As formula we writing n minus 2 c x minus 2. then followed by p power x minus 2 q power n minus x. Now these equation becomes as a binomial probability mass function, so that it will become summation p of x is equal to x. So it is nothing but 1, so that we get np square n minus 1. Now we keep it as equation number 3. Apply 3 in equation 1. Equation 2, we get mu2 dash is equal to np square n minus 1 plus np. So multiply inside np square n square p square minus np square plus np. Now the variance formula is mu2 dash minus mu1 dash the whole square. So when we apply mu2 is equal to n square p square minus np square plus np minus np the whole square. So np the whole square is nothing but n square p square minus np square plus np minus np n square p square. So it gets cancelled. We get, first we write the positive term np minus np square. Here we are taking np as common, so that we get 1 minus p. P plus q is equal to 1. So 1 minus p is equal to q. So we are taking 1 minus p as q. npq. Hence proved. Variance is equal to npq. Now for the subdivision, standard deviation is equal to square root of variance. So it will become square root of npq. Hence proved that standard deviation is equal to root of npq. So we have proved all the three subdivisions.